Thank you for a great introduction and good morning. Доброе утро. My origin is from, I guess, USSR or Russia is nowadays, so I can understand a few words in Bulgarian, and some of them don't quite mean what I think they mean, so I have to be careful what I think I'm saying or I think I'm understanding. So thanks for the great introduction. I now have one less slide to go through as a result. One thing I want to mention, so these slides I'm going to post on Joined In, and as Michelangelo made a really good introduction to Joined In, please leave feedback, good, bad, anything you recommend to improve. So don't worry about any code examples or URLs that I'm going to show, because the slides are going to be right at this URL, probably within the hour after I finish. So, as I said before, I can probably safely skip this slide. One thing I want to mention is that security has been one of my passions, and I find security particularly interesting because it's one of the fields where you are perpetually playing a cat and mouse game. Just when you think you thought of everything and you fixed everything there is to fix, there is some new vulnerability because somebody is a little bit more clever, they thought a little bit more differently than you have. So it's something that you need to think continuously about. Now, one of the things where I'd like to start with is there's a list of usual suspects, and I have to admit I took the OWASP, which is Open Web Application Security Project, took their top 10 list and just listed it here. Now, the one thing that is interesting is that most people talk about the first four, so the common vulnerabilities, cross-site scripting, CSRF, SQL injection, and so on. And as a let's call it a security professional, it's a little bit frustrating for me to talk about those topics, which I'm not going to cover today, by the way, simply because those are well-known problems, and there's a lot of great tools. In PHP, you have the filter extensions. For databases, we have prepared statements and a variety of other mechanisms to try to prevent those common problems. But what I see more and more is that there are vulnerabilities involving other means of breaking into the application. Some of them is a combination of a software vulnerability combined with a little bit of social engineering when you're trying to trick somebody into providing some pieces of information. And that's what I wanted to focus on today, which is some of the more esoteric security issues, which in my mind fall under the business logic security, that as somebody is developing applications, be it open source, closed source, whether it's a general package or an application in your particular work stream, that it's important to keep in mind. Now, one thing is that we have a small group here, so I welcome questions as I'm going through the presentation. So if you want me to clarify something, if you have any questions, raise your hand, and as long as I see your hand, I'll give you the opportunity to ask the question. I think we have a microphone also going around the room, so by all means, don't be afraid to ask anything. So the first thing I want to talk about is authentication. Authentication is the basic of any application that requires somebody to log in or have any sort of privileges granted to them. We all know the basic password rules. You want letters, numbers, special characters. The one thing that I find particularly amusing is that the recommendation of how long the password needs to be always keeps growing and growing. But one of the things I have to tell you is that if you follow the Open Web Application Securities Project recommendation that the password must be 10 characters, it may be a secure password, but your users will absolutely hate you because they will never be able to remember the password. And it seems every couple of years they add 2 more characters, so I wouldn't be surprised that by 2016 it will be 12-character long password. Nobody honestly can remember that. So usually I'd say 8 is good enough, but you have to think about other things that you can do to make the password more secure. And nowadays, especially, password security goes down to a couple of things. I took a diagram, I'm not sure if you can see it here, it's from LinkedIn hack, which was a couple of years ago, although I suppose I should update it to the Ashley Madison hack. How many people have not heard about the Ashley Madison hack? Okay, a few hands. So it was one of the, it's not quite an adult site, it actually is based in Toronto, which is where I'm from, but it's a website where people can, married people can find other people outside of their marriage that they can have a little bit of fun with. So obviously some sensitive information, and recently they were compromised, all their database, their source code, everything was published on the web. And one of the things that was published is their password database. So immediately people started using rainbow tables, GPU optimized hashing to try to break in. So, and as you usually find the most common thing. You have about 10 or 15 passwords that everybody is using. Password is one of them, QWERTY, ABC1234, all those common passwords are being used. So, and even when people are using uncommon passwords, the power of modern computers is becoming so quick that it's very easy to break in passwords. So one of the first things that you need to do is you need to make sure that you're not using MD5 or SHA-1 for your password security. You should be using salted passwords. You can use a crypt for that, where you're using something like a blowfish base. The second parameter there, the 10, is a cryptographic complexity. So rather than making your users pick a stronger and stronger password, you can actually make the cryptography become more and more complex. So somebody trying to break into the password, if, for example, your database is compromised, it'll take them that much more computing power to be able to guess what the password is. And then you have a little bit of randomness, which, if you're in the Linux platform, the best way to do it is to read it from dev-urandom, which is a very good source of random information. And then you end up with a 60-byte long string, and this string is effectively a password, and then you can use the crypt function as a means of validating that the password is correct. Now, this is the I would say the legacy compatibility way of generating strong passwords. If you're using PHP 5.5 and higher, you actually have a password API that makes it a lot more straightforward. You simply take the password, indicate that you want to use a bcrypt algorithm, indicate the cost, which you can increment over a period of time, and then you have a password verify function that allows you to determine whether or not the password you're supplying is strong enough or not. And this is basic rudimentary protection that you should be using for your passwords, because you can't assume that what's sitting in your database is going to be safe. History has proven that if somebody is really committed to breaking into your application, eventually they'll find your way. Even if all your code is secure, it's likely that they may send an email that will trick one of your administrators or support staff to giving them access they shouldn't, and the password will leak out and so on. But this is the basic stuff. Some of the things that I want to talk about now get to the logic aspect of it. So first of all, logging into the application is one of the most basic and usually one of the quickest thing within the application, because all it does is requires a single query to a database. So usually it tends to be very quick. And if you don't restrict how many attempts somebody is able to do, you actually are opening yourself to a brute force attack where somebody can slam the application with hundreds and hundreds of requests trying to guess passwords. And if one account doesn't succeed, they can move on to the next one and the next one and so on. So the first thing you want to do is limit the number of attempts that somebody can do when they're trying to log into the application. And once they reach that limit, you can implement a couple of different techniques. You can log them out for a period of time. So all future login attempts are going to be rejected outright. You can implement CAPTCHA, so to try to block various automated tools. Although nowadays, again, thanks to the power of modern computers, you can actually guess a lot of the CAPTCHAs fairly quickly. MultiFactor authentication using SMS or email is another really effective solution. Or security questions. Ask people security questions so there is additional layer of security before the additional attempts are allowed to go through. And the whole idea behind it is to protect that initial point of entry into the application. One other important thing is that you also want to set general limits, because if one account is now limited, you don't want to allow them to jump onto a next account and try again and again and again. And because there's so many different databases that are leaking out on the web, what people often do is they'll take, let's say, a LinkedIn login database, Ashley Madison login database, and they'll scan through that login database trying different logins, because people tend to be very predictable. If they use the same login in one application, chances are they may be using it for another application and so on. And most people's login nowadays is their email address. So the moment you know their email address, you pretty much know 50% of the authentication process. Another thing you can do, and this is largely to prevent automated tools, because very few hackers actually do what you see in the movies. They sit in front of the screen, usually black screen, a lot of green text starts scrolling, sometimes horizontally, sometimes vertically. That's not really how hacking works. Usually it's an automated program trying over and over again, or people trying to find a vulnerability. But I guess it wouldn't be a very entertaining movie. Probably last 20, 30 hours of somebody typing at a computer, not much else is happening. But for automated tools, obfuscation is not necessarily a bad technique. So instead of using the standard login and password fields, you can randomize the fields or use atypical fields, because a lot of the robots that are scanning applications to find a common application are looking literally for a field called login and password. Once they find it, they try to go through a database of their login and passwords and see if they're able to break in. So by changing those names or using random names, you're often able to eliminate that low-hanging fruit that an automated robot would be able to find it. One thing I should say, that's not to say that security through obscurity is your only protection, but as an additional layer to your other means of security, it's not a bad way of limiting the number of attacks to your application. The other interesting solution, and you actually see a lot of sites implementing it, Google is actually doing it, a lot of banks are starting to do it, is for every single user, they build what I would call a login signature. It's a combination of your browser signature, their IP address, and so on, to identify that this is what the user is using typically, because most people connect from the same set of 2 or 3 computers. So if somebody is, for example, connecting from a different browser signature with a combination of IP, maybe they're logging in from a hotel or a public computer, or maybe it's not them. So this is a good opportunity to present them with additional authentication to make sure they are who they are, and it's not somebody who broke into the application, because as I said before, people are pretty predictable. Chances are the same login and password they use in one application, they're using in another, because they can't be bothered to remember 30 or 40 different passwords, and not everybody has discovered password managers, right? So as much as we'd like that to be true. Now, one of the things I mentioned before is randomly generated field names. This is actually a technique that came from anti-screen scraping solutions, which a lot of sites that have valuable information have devised. But in PHP, it's surprisingly easy to develop. So this is actually kind of a quick example that I have. So inside my session, I generate a secret key, and I use it to hash the field names that I have inside my application. So every time a particular page, like a login page, would load, the field names would be different. So somebody writing an application needing to scan my login page actually has to parse my HTML every time, and because they don't know what the field names are going to be. So now they have to do a lot more effort in order to extract the data. Now, on the back end, it's actually pretty easy to process the data, because I read my form key, and then for every input field, I simply compare it to my database of the field names, convert my post parameters, and then present the input to the application. So it could be a little block of code that is sitting in front of your previous input processing, and if you wanted to, you could literally override the post super global with all the parameters, and your application continues as normal without any additional logic. Now, one of the other important things when it comes to business logic security is that once a person has logged in, you can't assume things are safe. So one of the things you need to do is you need to make sure sessions actually expire. They don't last for an extended period of time. And one of the other important things is that you cannot rely on people logging out of the application, or even waiting as long for a session to expire. So one of the things that I think we have downstairs at the basement of the shopping mall, I think there is a big computer store. So chances are, if it's anything like a big computer store in North America, there's probably a bunch of sample iPads and computers that people can play around with it to see how it goes. And whenever I visit those stores, at least every other time I see at least one computer logged into somebody's email account, because they wanted to see how their Gmail account will look on the latest, greatest laptop, and they forgot to log out. Sometimes it's a Facebook account, sometimes it's Twitter, all of those common things. So the reality is that people are very forgetful, and it's not an unusual pattern, which means they're leaving their account open for anybody to use. And an email account is particularly sensitive, because that's the basis of your authentication, like forget password functionality and so on, and to other different sites. So if you, with JavaScript, are able to identify that the user has been idle for an extended period of time, you don't necessarily want to wait for the session to expire, but you want to present them with a dialogue saying, hey, looks like you're not doing anything. Here's a little dialogue telling you maybe you should log out at some point. So there's URL here at the bottom, which is actually a pre-packaged jQuery code, which will allow you to implement that dialogue. It watches for events if somebody is doing something or they're just staring blankly at the screen. And it will present a fairly innocuous dialogue saying, hey, it doesn't look like you're doing anything. Do you want to continue? or no, and after 30 seconds, it will trigger the logout event and take the user out of the application. Now, again, one of the things with security is you always have to balance security and convenience, because one of the things I like to say a little bit tongue-in-cheek is that when it comes to security and usability, you can have one, but not the other. But there is this compromise somewhere in between. So one of the things a lot of sites like Amazon, for example, do, they implement 2 levels of authentication. You have authentication that you can remain logged in for weeks, even months at a time, but it doesn't really give you access to any sensitive information. But if you want to perform a critical operation, such as triggering a purchase or changing your profile details, at that point you have to re-authenticate yourself, at which point you get an elevated access or elevated set of permissions that for a short period of time allow you to make changes and other operations. So this is another very handy technique in terms of doing operations. Last but not least is you want to prevent duplicate logins, because typically speaking, most people would not log in simultaneously from different locations. One exception to that nowadays is that people have their laptop or desktop as well as a mobile device. But that's usually fairly easy to identify. You would not have 2 simultaneous logins from 2 laptops. That's usually a sign that somebody's trying to break in. And that's a good trigger for maybe presenting additional re-authentication mechanisms or logging both accounts out and requiring security questions to be answered before the user is able to leverage the application. So, on to the next topic, clickjacking. Anybody familiar with this concept? Okay, a few hands. So clickjacking is actually a very old technique where basically it involves tricking the user into performing an action on a site that they are authenticated with. The easiest example I would do, which was a very popular technique, and it's actually coming back now, largely thanks to Ajax, is let's say a website has a list of, let's say, blog articles. An authenticated user has the ability to delete the article by clicking a delete link. And the delete link is simply delete and the ID parameter in the URL. So somebody can send a lot of spam, HTML, containing HTML text, and inside that there's an image tag, size 1 pixel by 1 pixel, so you won't even see it. But the link to the image tag is actually a link to that blog with a delete link. If the user happens to be logged in, their mail client happily executes the HTML, deletes the blog entry. User is none the wiser that something, happened without their permission, but now there's some less data on some site that they had access to. Now, that's been talked about a lot, and very few people nowadays use those get links. But the reason this technique is coming back is because in the modern world, everybody's using Ajax. And when they're using Ajax to make requests, more often than not, they do it via get as opposed to post. So somebody can analyze a site, see which Ajax requests are being fired, and subsequently perform the same technique. Now, the thing is that switching to get method is not the only solution, because even post can be simulated. All it does, it requires you to embed the site inside an iframe and trigger form events and so on. So one of the really easy ways you can do that is by making your web server or PHP send xframe options header with a value of deny or same origin. So that means that you can embed your own application within itself, or you can deny any embedding no matter where the location is. And that allows you to prevent this clickjacking attacks where somebody is able to embed a portion of your application, typically using an iframe, and then interact with that iframe from another application, triggering post events and other different tricks. So very handy technique for that. Another thing you want to talk is transport security. Now, suffice to say, if you're using an application that involves any level of authentication, you should be using SSL or running over HTTPS. The one thing is that most people are not going to type HTTPS, your domain name, and so on. They're just going to type the domain name in a browser, or if they're typical user, they're actually going to type it into Google, and Google will find the site for them. Now, the challenge with that is that the browser, if it has cookies or whatnot, and the cookies have been set, it's not going to differentiate between SSL or not SSL. It may send sensitive data over unencrypted connection. So one of the ways you can educate the browser that the site always should be accessed via HTTPS is by setting the strict transport security header. And I have example here for both Apache and Nginx, which I would say probably the more common web servers that you have. And what it does is that for a very long period of time, including all of the subdomains that are of the site, it's going to instruct the browser that the preferred way of accessing this particular site is HTTPS. So when you type www domain name, after the first visit, the browser will know that it should be going to HTTPS and not go through the regular HTTP site, even on the very first request. So very simple way of ensuring that every time a user connects, there is actually an encrypted mechanism of passing over the data to the application. Session security, that's another really big topic, because in the end, once a user logs in, that little session token is their identity. Call it the passport to your site, if you will. So I like to use the PHP session extension as the basis of it, because a lot of the session handlers in the end are based on the session extension, or if they do their own implementation, in the end they share a lot of the same properties. So the first thing you want to do is you want to make sure that you're only using cookies. There's really no reason to be passing the session ID via the URL or forms and so on. It just opens it to session hijacking and various other attacks that much more easily. When you're generating session tokens, it's very important they're truly random tokens. So if you do happen to be using PHP, you definitely need to set those INI settings. And the reason for it being that the native PHP random session ID generator is actually not all that random. And it's susceptible to what's called timing attack, because it's based on the Unix timestamp, the PID, and just a little bit of randomness. So with about 500 to 1,000 requests, if you don't have the entropy file and the entropy length set, you can actually guess what the next session ID is going to be on the server by figuring out what is the exact time on the server, guessing the PIDs, because they're usually within a limited range of numbers, and voila, you can guess what the next user session is going to be. And once you know the session, you can just send that cookie, and voila, you're logged in as that particular user. So if you are using PHP session extension, just change those two settings inside your INI file, which will make your session IDs truly random. The other thing is you want to set the HTTP only flag, which means that JavaScript is not going to have access to the cookies. So if somebody did manage to inject some XSS into your site, they're not going to be able to use JavaScript to extract the cookie and transmit it to a different application, which will keep the cookie safe. And if you're using HTTPS, make sure that the secure flag is set, indicating that the cookie should be part of the encrypted mechanism. The other thing to keep in mind is please do not use the default session names like PHP SesID or JSesID and all those kind of things, because again, it's one of the things that a lot of the automated robots are looking for. Not to mention, if you happen to be using two applications on the same site and they're using the same session ID, all sorts of interesting bugs may appear because the two applications are overriding each other's session, which is a very amusing bug, but not so amusing if you actually have to fix it. The other thing is that don't trust session IDs. So when you initialize a session, by default, if the session was already initialized, it will continue using that session. That's a property of many session handling mechanism. So you can have within a session like __ validated flag. If it's not present, regenerate the session ID. And after that, you have a session ID that you can trust because it's your application that actually generated that particular session ID. One interesting little security topic is when you regenerate session IDs, it's important to delete the previous session if you're storing it in a database or on disk, because one of the common, a little bit, I wouldn't say too common, but one of the attacks that somebody could do is a denial of service attack against your session handler by making a ton of different requests with different session IDs. And because you regenerate the session ID every time you get an unauthenticated session, they're actually able to get you to write 2 entries for every single request, which acts as a multiplier, and it makes it that much easier for them to fill up your session handler, be it disk, database, memory, and so on. So if the session is not being used, and you happen to be using PHP, the true parameter to session regenerate ID will actually prompt it to delete the session ID that it's not being used and any relevant information that is associated with it, so that you don't have a denial of service attack, or it's much more difficult to trigger it. Now, the other topic I want to talk about is the data access management. So when it comes to data access management in the pre-MVC world, this was a typical scenario. So you have an action, you have some logic to perform, whether or not the user is able to perform that action, and then you go to the data storage, be it a database, MongoDB, NoSQL, disk, whatever. So the obvious problem is that because you're implementing the access control layer for every single action, chances are if there is some sort of a permission change or a bug, you fix it in 2 places, 3 places, but one of the rarely used places gets forgotten. And that rarely used place ends up being a way for somebody to break into the application, because it's impossible, especially in larger applications, to remember all the different areas where the authentication needs to occur and potentially needs to be updated in every change. Now, unfortunately, when you deploy MVC, it doesn't entirely solve the problem, because you have your different views, you have your controller, you have your model, and within the model now you have the different actions, and often enough those actions also implement their own access control layers. So just a typical MVC implementation does not necessarily resolve this underlying problem of having multiple layers of authentication for the same operation. So ideally, what you want is the following structure. So you have your views, you have your controller, then you have your access control layer sitting potentially right inside the model and centrally controlling access to whatever operation that you're doing. So to put it a little bit in a perspective of a code base, this is, don't copy this code, this is just a sample. Inside the constructor, you determine who the user is, whether they're administrator, user, or an editor. And then within that, you apply certain data access filters automatically to the data access layer. So to automatically perform the appropriate joins if you're using a database, or set the appropriate flags to restrict the user's access to just what they're able to perform, and do that centrally as opposed to on a localized basis, one part of the application by another. And that's a really easy way, and obviously you can apply it to your own application as you go. Another thing that is very important for a couple of different things is Audit Trail, because an audit trail gives you information about what's going on in the application, and there's all sorts of benefits to debugging. There's actually a talk, I believe, later on tomorrow all about logging and the benefits of logging. So if you're interested in that, you can find out. But logging is actually quite important for security purposes, because one, if there is a security breach, detailed logs are going to be able to help you identify what is the scale of the problem, so that you're able to identify what went wrong, what potentially was exploited, give you a quicker path to a resolution, and in many cases maybe even tell you how you can revert the changes that the unauthenticated user has performed on behalf of somebody that they were becoming with. Debugging purposes, but the other really big benefit, and this is something that's interesting, is most hacking, even social engineering, involves a lot of trial and error. So if you have detailed logs, you're actually able to, through patterns, identify what I would call unusual behavior, things that are atypical. So for example, if your typical use patterns are that people access your application from 7 a.m. to 10 p.m., and all of a sudden you have a lot of activity between 2 a.m. and 4 a.m., which is one of the windows that hackers really like, because usually there's not much going on servers, so the servers have very little load, so you can send a ton of requests to those servers without them generating alerts. Administrators are usually asleep, so there's nobody around to address those concerns. And if you're buying CPU power, usually at night is the time where it's the cheapest. So if you need to bring up a lot of AWS instances to hammer something, there's usually some cost savings to doing it late at night as opposed to the middle of the day. So if your application is able to automatically detect the unusual patterns, one, you can trigger alerts, or two, you can actually implement additional lockdown mechanisms in order to do that. And the best way of doing it is by having some basic rules that you can evolve over time. And you can even develop patterns for user-by-user basis, like when do users typically access application, what operations they perform. So to give you an example, if most people who access an application will spend 5-6 minutes, access 10 or 15 pages, and then they're gone. If all of a sudden a user logs in and they start accessing hundreds and hundreds and hundreds of pages, chances are this is a robot that logged into the application, or somebody broke in and they're now trying to retrieve as much information as they can before the access becomes locked out. And this is a good prompt again to trigger additional authentication parameters which the user needs to supply before their access is continuing. So depending on your particular application, you can deploy various different means, but the only way you can do that if you have detailed logs where you can actually use things like machine learning, or even some of the simpler techniques to identify what is a typical behavior of a user, and if something does not fall into that particular set, then you can do something to address it. And as I mentioned before, you often will have a revert path because you're able to identify what the user has done and subsequently address that issue. Now, how can you implement this type of information? So when it comes to any type of logging, you want to do it on the lowest level possible, because the more dependencies there are, the more likelihood there is that something is not going to work if your database is not accessible or, or something, and you're not able to record the data. So ideally, you want to do it inside the model. You can do it inside a database as well, although doing it inside a database is a little bit tricky, because inside a database, you usually don't have a context of who is performing the operation. So the only way you can do that is by using things like stored procedures, injecting into stored procedures the ID of the user who's performing that action, so the stored procedure can do additional logging. So inside the model, on the other hand, you have all the information available. So this is, again, another little mock code that I've designed. So before performing any, let's say, update operation, you can fetch the previous record, use an array diff to see the difference between the existing state and the new state, and if the save operation was successful, then you can log the data. But you'll notice here that I'm doing it within the context of the same transaction, because one of the things you want to tie things to is to say that if the ability to log the data was unsuccessful, you're not able to write the audit trail, you don't want the transaction to occur. So the transaction is effectively dependent on you being able to successfully record the fact that the transaction had occurred, and the two are directly related, because in some cases, you don't want to have a situation where somebody can realize you're not using transactions and they can abort the request before it's able to finish, and the data modification operation was successful, but the logging of the operation was not because the request was aborted, which is another good reason why you want to use ignore abort INI setting in PHP, which allows the request to continue even if the user closed their browser and effectively said that they're not interested in the outcome of that particular request. So talking about a little bit more about the unusual patterns is, one of the things that's important to keep in mind is that there are known vulnerabilities, and known vulnerabilities are the things that are published on security lists and so on. But often enough, it's the unknown that is the most dangerous one, because nobody knows about it. And to get to unknown, there's a lot of trial and error that is happening within the application, and that trial and error is very easily detectable. So log files, web server log files, application log files, and so on, that's the kind of stuff that you want to look for. And you can look through an unusual number of requests, as I mentioned before, late night accesses, or even a lot of requests within a short period of time. As quick as people are, nobody needs 10,000 pages within a span of a minute. Nobody can read that quickly. And nobody can even press refresh that quickly, unless they're, putting their stapler on their keyboard. But even then, it's only about 60 hertz, so you're limited to about 60 or 70 requests per second. The other thing, and this is another interesting topic, is that a lot of people talk about you have to filter your inputs, you have to, escape your outputs and so on, but they trust the internals of their application. And it's actually a commonly false assumption. You need to make sure that even on a low level, be it your model or be it your controller, you validate the information, because in order to keep things secure, you absolutely cannot trust even the insides, because one of the interesting attack vectors is to combine two seemingly safe inputs together. And by combining those two inputs, you're actually able to trigger an error message or inject some vulnerability into the application, be it XSS or some other parameter. So even at a low level, you want to make sure inputs are filtered. And one of the easy way to do it is to, once again, use the PHP's filter extension. There is a really helpful function there called filter var array, which allows you to define an array definition of all the parameters that, let's say, a function expects, and provide validation. So you have your booleans, you can use regular expressions. For integers, you can even define integer ranges so that people can't rely on things like integer overflow within the database or whatnot to provide a large value, which is a common issue when people use isNumeric, because isNumeric is going to return true, and even if you give it an integer that's 10 or 15 characters long. But if you're using a 32-byte integers, then it will overflow several times for something that big, and that could actually trigger vulnerabilities where you supply a limit statement that causes the database to go nuts because it's get a negative value, and in some versions it can actually be used to trigger a denial of service attack and so on. So it's a very easy thing to do, and then you simply supply all your input, and the filter filters it out, and if there's any issues, then you can trigger an exception and exit out of the application. And one of the things that I want to mention on this thing is that if you have invalid inputs, one of the common mistakes that people do is they normalize the invalid input. Oh, I got a string when I expected an integer, I'm just casting it to an int and I'm proceeding forward with a value of 0. If you get an unexpected input, usually the safe way of doing it is triggering an error and having a generic error page saying some error have occurred. Don't give a user necessarily a clue of what went wrong, because that can help an attacker to figure out what validation you're doing and assist them in figuring out how to potentially try to bypass that particular validation. It's actually one of the few good things in the PCI certification guide where it say you shouldn't have specific error messages, but rather generic ones and so on. Remote URL access. Another interesting attack vector is more and more applications nowadays rely on APIs to access data from external data sources. And that involves making SOAP requests, making HTTP requests, and so on to other applications. So whenever you're doing that, you should always try to use HTTPS. To me, it's always frustrating to see when somebody's publishing an API for, let's say, a payment gateway, and their default access is via HTTP. It's like, really? So even if they don't publish the secure site, always on your own try to see if the secure gateway is available. Usually it's just the omission in the documentation and the secure gateway is in fact there. When you're accessing via a secure site, make sure peer and domain verification is enabled, because DNS can actually be spoofed relatively easily. If you read security blogs, you probably read over the last couple of years all sorts of DNS hijacking attacks and so on. And if you're using curl in particular, know what the settings means. I'll show you that in a slide or so, because curl settings are a little bit unobvious. So if you're not using curl, you're using PHP. PHP file requests are able to take context. And the basic context configuration is you say enable verify peer, match the domain name, match depth 5, so go through all the certificates because there may be child certificates available. And you want to have a PEM file, which is basically the latest list of CA certificates, because as the SSL certificates from the various issuers expire or become compromised because for some reason they decided to issue google.com SSL to somebody who's not Google, their certification is now revoked and they get a new one. You need to make sure you have an up-to-date cert file, and if you don't have that one on your OS, which most distributions do have, you can actually retrieve it yourself from the curl URL there above, and that'll tell you that particular information from there. If you are using curl, it's very simple. The only really setting you want to set is the path to the latest CA info, which is the same bundle of valid issuers. The one thing you want to be careful with is the two settings, curl opt SSL verify peer, which should not be set to false. It's actually set true by default, so it's a good setting. And the more tricky one called verify host, and this is where a lot of confusion comes in. A lot of people just set it to true or 1, but the real setting is 2. So that's where the confusion is. If you set it to 1 or true, it actually turns off one of the security settings. And the one example I have of is in Canada, one of the big payment processors is Moneris. So they not just provide APIs, they also provide the hardware that you can use to process cards. And they published the PHP API, and they actually decided to set verify peer and verify host, both one of them to false, the other one is to 1. Because at the time, even in their comments, they said, too many applications have issues with SSL because they don't have the right CA bundle, so we'll just turn off the verification so that people don't get errors inside their application. Not probably the best setting for an application designed to process payments, but it is what it is. So make sure that your settings, ideally you don't even need to change the curl settings, so leave them there, and from there you proceed. PHP error handling. One of the things I want to talk about is that you want to log every single error. The reason you want to log every single error, it could be, 1, helps you to debug. 2, it gives you an idea if somebody's trying to break into the application, your application start generating errors, what you potentially need to address or fix. Every error should be logged. Login should not have any dependencies. The best target for logs is actually disk, because disk is pretty safe. It doesn't add latency overhead, which is some network or database-based logging will have. If you want to aggregate your logging, you can use syslog. And disk can always be aggregated by some batch process once a day, once a week, even every few hours. And one very important thing is there's no such thing as a trivial errors. In our particular code base, one of the things I like to do is I like to set up a error handler, and no matter what type of error occurs, it converts it to an exception or a fatal error, so that even most trivial errors need to be addressed by the code base and they abort the running of the application. And for the love of God, please set display errors to false. Google made my life a little bit difficult, because in the past I could just type some interesting queries into Google and show all those things. But Google actually decided to protect the guilty, and they don't allow you to run the regular expression. So now I have to use DuckDuckGo that hasn't filtered that information yet. And you can find all sorts of fun, you can't see it here, probably for the best, all sorts of MySQL connect errors. Sometimes you can get logins, sometimes host names, and even in some error messages you can even get passwords. So all sorts of fun things. So please keep your errors display false. It's a debugging setting and should not be enabled anywhere outside of your dev environment. So on that note, thank you very much for listening once again. The slides would be at this URL. I would welcome your feedback. I've been getting various signs around timing, so I'm not sure if we have time for questions. So we do have time for questions. Great. So if you guys have any questions, I'd like to open up the floor for any questions, any clarifications that you'd like to know.
I have a question. Is it on? Yeah, it's on. So what do you think about sanitizing the input also from APIs and not just forms and data that users go into your sites?
Well, I would say that there's no such thing as safe input. Even API could be compromised. API may send data that may be fine. So I'll give you one example. So API may send you data in UTF-8, and maybe your application is not able to handle UTF-8 or in a particular format, and that can actually trigger issues. In some cases, it may send you UTF-8 that's not valid, especially if it came from copy and paste from Word or Excel, and that may trigger vulnerabilities. When I give my other security talks, I actually showed an example where you can bypass escaping in MySQL by using an invalid multibyte sequence, which the active escaping converts into a valid multibyte, removes the escape character, and now you have SQL injection, all thanks to just a couple of little, invalidly formed multibytes. So there's no such thing as safe input. Whether it comes from API, whether it comes from other part of your application, always validate, always certify your input. Don't trust anything. That's the rudimentary premise behind security. Nothing is trustworthy.
Totally agree. Okay, so that being said, we would like to thank Ilia.
Oh.